This is another example on applications of resultant forces. The body P shown in the diagram above is in equilibrium. If the mass of the body is 10 kg, calculate the tension T and force F. This body P shown in the diagram above is in equilibrium. If the mass of the body is 10 kg, calculate the tension T and force F. This is a WAEC question. So let's look at how we solve it. This diagram is what you are given. That is the body. And the pull force. This is the tension. This is the force. And you have angle 60 in this place. Now before you can solve this question, you should recall that the weight of the body will act downward. The weight of every body or object always acts downward. So the weight of the body P will act in this direction. And don't forget that weight is equal to mg. W is equal to mg. Then after that, you need to first complete this triangle. If I complete this triangle, I can bring it out. I'll look for my adjacent and opposite. If I bring this triangle out, this is what I have. Then I need to find this place. If I consider this triangle, the side that is facing it here, this is my opposite. The side that is here, this place will be my adjacent. And this side that is facing the 90 is my opposite. So I need to first find this adjacent and opposite in terms of this T. To find this adjacent and opposite in terms of T, I will have, don't forget from our SOCATUA, opposite and adjacent. Opposite and hypotenuse is sine. Sine, opposite and hypotenuse. Cos, adjacent and hypotenuse. Tan, opposite over adjacent. So because let's say I want to find opposite and hypotenuse, that's sine. Opposite, hypotenuse, that's sine. So using sine 60 is equal to opposite over hypotenuse. Then that means sine 60 is equal to opposite over T. This over 1. If I cross multiply now, opposite times 1 will be opposite. Is equal to T sine 60. So my opposite, this side now, is T sine 60, which is the same thing as this place. That means this place is T sine 60. Then I'll get my adjacent. Adjacent and hypotenuse, that's cos, car, adjacent, hypotenuse. So in that case, I will do that now. I will have cos 60 is equal to adjacent over hypotenuse. So in that case, I will have cos 60 is equal to adjacent is what I'm looking for. Then hypotenuse is T. This over 1, if I cross multiply now, my adjacent times 1 is adjacent will give me T cos 60. That means this adjacent now is T cos 60. That means this place is T cos 60. And don't forget that this side will be equal to this side because this place will be equal to this place. If there is a force acting like this, it must be equal to this. So this place now is T cos 60. And you go from parallelogram law that upward force is always equal to downward force. Leftward force is always equal to rightward force. So upward force now will be equal to downward force. That means this one upward will be equal to this one downward. So T cos 60 will be equal to W, which is equal to mg. That is, I can have that one here now. You can have T cos 60 is equal to W. That means T cos cos 60 is equal to mg. Then you have T cos 60 is equal to 10. Mass of the body is 10 times G, which is also 10 here. So you have times 10. So you have T cos 60 is equal to 100. Then T is equal to 100 cos 60. So 100 cos 60 will give us 200 Newton. So my T is 200 Newton. Then to get my F, you recall that rightward force will be equal to leftward force. Rightward force will be equal to leftward force according to the law of equilibrium. Upward force is equal to downward force. Rightward force will be equal to leftward force. Then that's what makes this body to be at equilibrium, which is the condition that we are given here. The body P shown in the diagram above is in equilibrium. If the body is in equilibrium, it shows that upward force will be equal to downward force. Rightward force will be equal to leftward force. Then in that case, it means that this one, rightward, will be equal to this. That means in that case, F should be equal to T cos T sin 60 equal to T sin 60. And F is equal to, my T now is 200. We have gotten T. That will now be 200 sin 60. So you have F is equal to 200 sin 60. So you have 200 sin 60. That will give me 173.2. 173.2 Newton. This is also another example on the applications of equilibrium of forces. So this is another example. Subscribe to our channel if you are new and turn the notification button on for more examples on applications of resultant of forces. Thank you.